Okay, students, so next is question number 4. So we have to differentiate this one with respect to x. So first what we will do, let y is equal to sine tan inverse e to the power minus x, right? So this is your question. So we have to differentiate this one. Differentiating with respect to x, what we will get, dy by dx is equal to, now this one is in which form? Let me write down first. ddx of sine tan inverse e to the power minus x. Now don't get confused here, student. So this is not product. Some student, what they might think is uv form. This is not uv form. You can see this is sine angle. Sine alone does not have any meaning, remember that. So sine x form, this one. Okay, so if this is sine x form, what is the differentiation of sine x? It is cos of x. This is your x. Now in place of x you have this, so we have to differentiate this one again, right? ddx of tan inverse e to the power minus x, you have to differentiate again. Now this one of the form tan inverse x. Now remember, tan inverse x I have asked you to derive it yourself, right? So what is the derivation of this one? If I show you separately again this one, this will be the differentiation of tan inverse x. If your function is tan inverse x, what is the differentiation? If I differentiate this one with respect to x, I will get 1 by 1 plus x square. You can try this yourself also. Okay, we have done this one, this kind of question actually, and I've asked you to do it, and try to remember tan inverse x, ddx of tan inverse x is equal to 1 by 1 plus x square. You will keep on needing this one, right? So you better try to remember this one. Okay, ddx of tan inverse x is always 1 by 1 plus x square. So this one is also ddx of tan inverse x form, right? But in place of x you have difference, so you have to differentiate that one again. So this you will get cos tan inverse e to the power minus x. Now differentiation of this one will be tan inverse of x form, what it is, 1 by 1 plus x square. Don't get confused, don't write this one sec square here. This is not normal trigonometric function, this is inverse. Okay, tan inverse x form, so it would be 1 by 1 plus x square. Now in place of x what you have, e to the power minus x. So this you have to differentiate, this portion you have to differentiate again. Okay, so if I differentiate that one again, what I will get, cos of tan inverse e to the power minus x into 1 by 1 plus e to the power minus x. If I differentiate this one, this is of the form e to the power x, right? So e to the power x, it was e to the power x only, right? But since you have in place of x different minus x, right? So minus x, if I differentiate again, what you will get, minus 1. So minus will come here. I hope you can understand. This is of the form e to the power x, but in place of x what you have, minus x, right? So minus x you have to differentiate again. E to the power x form, what is the differentiation? E to the power x only. So same thing I have written. Then in place of x you have minus x, so minus x you have to differentiate again. So when you differentiate minus x again, what you will get, minus 1, right? So minus 1 means minus will come here. Okay, so if I arrange this one properly, what you can write this one, minus e to the power minus x by 1 plus e to the power minus x cos of tan inverse e to the power minus x. Achha, one thing I have missed out, I guess, right? This is of the form tan x, tan inverse x, so it should be 1 by 1 plus x square. This should be square, right? So here it will be 2. Okay, square this will be minus 2 2x. Okay, if you haven't understand this one, you can put bracket here, put square here, then power will get multiply, right? So 2 into minus x will be minus 2x. Okay, if you get confused how I have written the square, if you have confusion, this is your x right here. So x square, whole square you put it, power will get multiplied, so minus 2x, minus 2x, minus 2x will be there. Okay, so this will be your answer. Next will be your number 5. So number 5, what it is? Log of cos e to the power x. So this is of the form log x, right? Not product. Again, don't get confused. This is not uv form. This is log. Log alone does not have any meaning. So with x, this is of the form x, right? But in place of x, you have different. So we will differentiate this one again. Okay. So differentiating directly, I'm doing differentiating with respect to x. What you will get? ddx of log of cos ex. We are going to differentiate this one. So this is of the form log x. So log x, what is the differentiation? 1 by x, right? So cos ex. But this one, in place of x, you have something different, right? Chain rule we have to use again. So this is again, this is not uv form. This is cos x form. Okay, cos x. Don't think that cos and this multiplied, so uv form. Cos alone does not have meaning. So cos x form means what is the, okay, let me write down ddx of cos x form, but in place of x you have ex, so you have to differentiate that one again. So ddx of co means minus will come, sine x, but in place of x you have ex, so you have to differentiate ex again. So ddx of ex is ex only, right? So you will get, if I arrange this one, ex minus will come here by sin ex by cos ex. So this I can write tan ex, right? Minus ex tan e to the power x. So that will be your differentiation. Number 6. Ex plus e to the power x square plus dot 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 e to the power x to the power 5. So this is differentiating with respect to x, right? So what you will get? ddx of ex plus ddx of, you just write down same format here, okay? Let y equal to this, then differentiating with respect to x. So dy by dx equal to this, you write down. I'm writing it directly. So very few term will be there, right? So let me write down all the terms here. Next, what will come? E to the power x cube plus ddx of e to the power x to the power 4 plus this one, right? This is the last term, ddx of e to the power x to the power 5. Okay, x with power 5, this one, which is equal to, so ddx of ex is ex only plus ddx of, oh here I have not written, ex square. So ex squared, so this one ex form, but in place of x you have x squared. So first thing, ex ddx of ex is ex only, but in place of x you have x squared, so you have to differentiate that one again. So what you will get here? 2x again. Okay, plus ddx of this one also ex form, but in place of x you have x cube. So ex, first thing it will be ex only, x cube again, if you differentiate 3x square you will get, plus this one again 4x cube e to the power x to the power 4, plus this will give you 5x4. Remember, one power less always, right? E to the power x to the power 5. Okay, so this will be the differentiation. So you can see within one step you can do this one. The thing is, you know the differentiation well or not. That is the important question here. Okay, if you know well, you can do it in one step also. Next question, number 7, right? So number 7, root over e to the power root x again. So inside root you have e to the power root x again. So with what form it is? Root x form, but in place of x you have difference, so we will differentiate this one again. So this is root x form, so d dx of root x. This is your x here. So root x, what was the differentiation? 1 by 2 root x, right? So in place of x you have this one. So we will differentiate that one again. E root x. So this will give you 1 by 2 root e root x. Then this one again, if you differentiate e to the power x form, right? So e to the power x form means e to the power x only, right? But in place of x you have root x, so we will differentiate that one again. If you can do it in one step only, means here only you can do it, okay? So 1 by 2 root e to the power root x, e to the power root x here, ddx of root x is 1 by 2 root x. Okay, so if I arrange this well, 2 into 2, this will get multiplied 4 e root x, here again root, here above what you have, e root x. Okay, so this will be your answer, right? If you want, you can cancel this one with this actually, right? If I write this one, root e to the power root x into e to the power root x, means rationalization if I do. And one more root here, right? Root x also is there, this root x. So this root x I can put it inside also, right? E to the power root x, root, you know, right? Root 2 into root 6, I can multiply this one and can write root 12, right? You know that. So this root x I can write it inside also, 4x e root x, means this and this we have multiplied. Okay, you can take rationalization or you can leave it like this also. Okay, so next is question number 9. Sorry, 8, right? After this 8. So question number 8, log of log x. So this is of the form log x. Don't think again uv form. Log alone does not have meaning. Log x form. So ddx of log x. So what it will be? Log x. ddx of log x is 1 by x. So in place of x you have log x, right? So log x again I have to differentiate. So ddx of log x. I hope it's clear. This is of the form log x. In place of x you have log x again, okay? So if it is log x, the differentiation is 1 by x. 1 by x. This is your x right now, okay? So since you have difference, so we will differentiate this one again, chain rule, okay? So ddx of log x is equal to how much? 1 by x. So this will give you 1 by x log x. That's it. Next, number 9, cos x by log x. Now this time it is, let me write down directly here only, ddx of this one. This time it is of the form uv. U is this one, v is this one. So log x whole square, log x I will leave it as it is, cos x I will differentiate. Co means sine of x, minus cos x I will leave it as it is, log x I will differentiate, 1 by x. So what you will get, minus sin x log x minus 1 by x cos x by log x square. Okay, so this is your differentiation. Next, number 10. Number 10, cos of log x plus e to the power x. Again, this is of which form? Cos x form. Cos alone does not have meaning, so cos in bracket you have this, right? So x, this you can take it as x, cos x. Cos x, what is the differentiation? Let me write here, ddx. Okay, or you can take this one as cos a plus b form also, you can break it, that will become lengthy only, right? So let's do directly. Cos x form. So cos x, what is the differentiation? Minus sin x, right? Minus sin x, but in place of x you have this, so we will differentiate that one again, ddx of log x plus ex. minus sine log x plus ex. ddx of log x will be this, I can break, right? Split plus, so log x differentiation 1 by x plus differentiation of ex is ex only. This is again multiplication with this, okay? So I think you can leave it, or you can multiply this and this. What you can write, minus 1 by x sine log x plus ex plus minus minus ex sine log x plus ex. Okay, so breaking will become lengthy, right? You can leave your answer here also, okay, or you can break and leave your answer like this also. Okay, so I hope exercise 5.4 is also clear to you, right? So you just practice a little bit, see the examples also which are given in your textbook. Okay, so we will discuss tomorrow again another type of logarithmic functions. Okay,